Alright, Alex, I'm going to go ahead and try to help you as much as I can with the problems that you're having trouble with. The first one that your mom sent me was this one. It's the one that starts off with Riley makes a mistake in step 2. That's the original problem right there. So your first step that you want to do with this one is you want to factor out this trinomial right here. That's the one that you want to factor. So for step 1, I would have x over, and that trinomial factors out into x and x right here, and then two numbers that multiply to get you 6 but add up to get 5 are 2 and 3. And then of course you want to take care of your signage from there, and you want a negative 5, and that happens with both of them being negatives. And then everything else remains the same, so plus 3 over x plus 3. Now from there, technically the next step, which would be step 2, is to find the common denominator, because here you have two fractions with different denominators. If this were regular numbers, for example, if you had 1/3 plus 1/2, you wouldn't be able to add those up. You would have to find a common denominator, which in this case would be 6. So look at what I'm going to do here. In order for me to get 6 here, I have to multiply that 2 by 3. And whatever I do to the bottom, I have to do to the top. Likewise, here, I'm trying to get a 6 because that's the common denominator. So what I have to multiply that 3 by is by 2. And whatever I do to the bottom, I have to do to the numerator. Now, that's the exact same thing that I'm going to have to end up doing here. However, now you have expressions to deal with. So, I call it going fishing. So, for example, you probably want to start off with the least one or the smallest one. This has too much stuff, so start off with the one that just has one set. And so, you stay here and you look at over here, and you see what you're trying to fish for. Well, you're trying to fish x minus 2 and x minus 3. And whatever you do to the top, you do to the bottom. I mean, to the bottom, you do to the top. So x minus 2, x minus 3. Now, here, if you move on to this part and you look over here at this part, well, you already have the x minus 2. You already fished that. You already fished the x minus 3, so really the part that you're missing is the x plus 3. Alright, and whatever you do to the bottom, you do to the top. So technically, step 2, and I'm not sure because I can't see the answer choices from the picture that your mom sent you, step 2 should technically be x times x plus 3 over x plus 3, x minus 2, x minus 3, and then plus 3 times x minus 2 times x minus 3 over the exact same thing, x plus 3, x minus 2, x minus 3. So something along those lines is what your explanation or your answer should be. So I hope that one helps you out. Alright, moving on to the next one. Let me look at it on my phone right quick. I'm going to skip the one that I have here because I'm going to save that one for the last one. Let's look at this one that says, which statement is true about the discontinuities of the function? So you have the function right here that says f of x is equal to x squared minus 4 over x cubed minus x squared minus 2x. Alright. So what we're going to do here is we're going to factor. Every time you have a rational expression or a rational function, factor it out. So this is the same thing as on the top we have a difference of squares. X plus 2, x minus 2. There you go. On the bottom though, that x can be factored out first, and so you have a quadratic in there, which is going to be x squared minus x minus 2. You're still not done yet because this quadratic right here can still be factored. So if I continue factoring, you officially have x plus 2, x minus 2 on the top, that never changed. On the bottom, you still have that x there. This right here factors out. So you have x and x, that's where you get that x squared. Two numbers that multiply to get you 2, 1 times 2, perfect. And you're trying to get a negative 1. So the way that happens is with a negative 2 and a plus 1. Now, what you want to see is, well, is there anything that I can cancel out from the top and from the bottom? From the top and from the bottom. Well, yes, there is. This right here. Those are called removable discontinuities. Remove it. So, for example, you have a point. It's shaded in. You know what I'm going to do? I'm going to remove that shade away from it. So when I remove it, you're going to have a hole there. So what do? You're going to take that x minus 2, set it equal to 0, and solve for it. So then you have x is equal to 2. Now in your answer choice it says a hole at 2 comma 2/3. Well, the way that they got that 2/3 was by plugging it into this part right here. Let's see, 2 plus 2 is 4, 2 plus 1 is 3, times 2 is 6, and then 4 over 6 gives you that 2/3. Okay, you plug it into the part that's quote-unquote reduced, where these two canceled out. You don't plug it back into the original, you plug it into this part here. Now, what's left, you always are concerned with the bottom. Those are your points, or those are going to be your asymptotes, because they are not removable. So this one is going to be x equals 0. There you go. And this one, set it equal and solve, and you get x equals negative 1. So these right here are your asymptotes, x equals 0 and x equals negative 1. And this one here is your removable discontinuity, because you removed them. Therefore, it created a hole at x equals 2. And when you plug this 2 back in here, you get your 2/3. Alright, the next one has two functions, and it says which statements comparing the graphs of function 1 and function 2 are true, and check all that apply. So we have function 1, you have x squared plus 3x minus 40 over x minus 4, and I'm going to go ahead and factor that out. So this becomes x and x, two numbers that multiply to get you 40 but add up to be 3, and that's 8 and 5. You're trying to get a positive 3, so that happens with a positive 8 and a minus 5. There you go. The next one, function 2. X squared plus 4x minus 32 and x minus 4. So you have x and x again here, two numbers that multiply to get you 32 but add up to be 4, and that's 8 and 4, and you want a positive 4, so that happens with a positive 8 and a minus 4. But look, right here, removable discontinuity. So all you really have left here is x plus 8. Nothing cancels out right here, so it kind of stays as the original, if you want to think about it that way. It stays as the original. Alright, so far we're good. Now, because this had a removable point of discontinuity, that creates a hole. Remember, it creates a hole. So you take that x minus 4 equals 0. X equals 4. So function 2 has a hole. Function 2 has a hole. And since nothing canceled out here, this right here, function 1, has an asymptote. Function 1 has an asymptote. Now, the next thing that you want to notice when you're dealing with this is a little it's not like really official, little, I guess, piece of information that I tell my students to kind of remember. Bobo Botan eats DC. And this is kind of helpful like on the SAT and the calculus tests, AP tests. If the exponent is bigger on the bottom, your asymptote is 0. Your horizontal asymptotes and vertical asymptotes. If it's bigger on the top, it's none. It doesn't have any. And if the exponents are the same, you divide your coefficients. You divide your coefficients. And it's not official because when it's none, it doesn't necessarily mean that it's none. There is a possibility that in that none is an oblique asymptote or slant asymptotes. They're the same thing, oblique, slant. I don't know which term your teacher uses. So if you notice here for function 2, we were just left with an x plus 8. That's just a linear function. So therefore function 2, let's see. Function 2 doesn't have an asymptote. There we go. I lost my train of thought. Function 2 does not have an asymptote. Now, function 1, look at it. The highest exponent is bigger on the where? On the bottom or on the top? On the bottom, so bigger on the top. So it's none, but in this case, because of your answer choices, it could have the possibility of having an oblique asymptote. So that's why the option that says function 1 has an oblique asymptote, yeah, that could happen, while function 2 does not, because it creates that x plus 8 once you factor and cancel. And then finally, they both have the same restrictions. Restrictions are basically looking at the denominator. You always want to be careful at looking at the denominator. There is a restriction because you cannot have 0. You cannot divide by 0. So if you look at it, they both have that x minus 4. And when you solve for that 4, you have x equals, or when you solve for that equation, you have x equals 4 for both of them. Now here, it may be it'll be an asymptote. Here, that restriction will be a whole. So asymptote or whole is included in the word restriction, and they both have something at x equals 4, if that makes any sense. Oh, excuse me. The next one is alright, so let me go back to the one that has the two functions, f of x equals x squared plus x plus 1 over 6. I'm going to go ahead and say, distribute and say 6x minus 24. You're comparing the steepness of the oblique asymptotes. And then you have g of x equals x squared plus x plus 1 over 8 times x minus 4. Oh, I should have distributed. That's fine. All right, so when you have to compare your oblique asymptotes, I know some of y'all don't like this, but you have to basically long divide. So I'm going to have to say x squared plus x plus 1 divided by 6x minus 24. All right, so this is going to deal with fractions. If you multiply, what times 6 will give you just a 1x squared? And that happens with the 1/6x. How do you know if you're right? Multiply back in. 1/6x times 6x gives you just the 1x squared. And you have to multiply it here too. 1/6x times a negative 24 gives you a minus 4x. And then from there, you subtract, or you change signs, basically. So I'm going to change this to a minus, this changes to a plus, this cancels out, and then you have 5x plus 1. And then again, you say what times 6x gives you 5x? Well, that happens with plus 5, 6. 5, 6 times 6x gives you 5x. And then 5, 6 times negative 24 gives you a negative 20. Change your signs, minus, plus. So So you have a remainder of 21 because this cancels out. So what happens? This right here is a linear. That's your asymptote. It's a linear function. It's a line. And remember, that's why it's also called slant asymptote, because lines are slanted. Lines are slanted. You're going to do the exact same thing here. X squared plus x plus 1 divided by 8x minus 32. So what I did is I distributed that 8. Now, what times 8x gives you x squared? Well, 1/8 x. Multiply back through and you get x squared and then minus 4x. Change your signs. Plus, no, I'm sorry, not plus. Minus and a plus here. So you get this to cancel out and you get 5x. Bring this down, plus 1. Now, what times what? What times 8x gives you 5x. So that happens with a plus 5/8. Multiply that through. 5/8 times 8 gives you a 5x. 5/8 times a negative 32. Let's see. 5 divided by 8 times gives you a negative 20. Subtract, subtract or change your sign. So this becomes a minus, this becomes a plus. So you get a 21. So this really doesn't matter. We're really concerned with that part. And in specific, we're really concerned with the slope of a line, which is this one. Because slope of a line tells us the steepness. Well, between the 1/6, if you have to change it to a decimal, you can. This is 0.167, and then 1/8 is 0.125. The bigger the number, I say this, SS. The bigger the slope, the steeper it is. S squared, if you want to think about it. The bigger the slope, the steeper it is. Out of these two, which one is the bigger number? This one right here. So that's why function f is the steepest one for its oblique asymptote. And then finally we move on to that table one. So what you want to do here, this is just basically averaging. So what you want to check is to make sure that the table has the volume and it's consistent. So for example, for 60 gallons per hour, if you multiply that by its time, which is 300 hours, your hours cancel out and you get 60 times 300, 18,000. And I'm not going to do it for each one of them, but if you take your time and you go through each part on the table, you'll get 18,000 every time. So for the second one, you'll say 45 times 400. The third one, 36 times 500. And then the last one, 30 times 600. And you will get 18,000. So that means that it is a good table, basically, if you want to look at it that way. So the total volume is 18,000. Well, you have two different houses. One that has a pool, one that is 40 gallons per hour and one that is 60 gallons per hour. So what you're going to do is you're just going to add those so you can get the total rate for that. So 40 plus 60 gives you 100. And then from there, what you do is you take that 18,000 volume and you divide it by 100, because 18,000 volume, well, let's see, 18,000 gallons divided by 100 will give you, let's see, 18,000 divided by 100 will give you 180 hours. It's really more kind of like averaging. Alright, so I hope that helps. If you still have trouble, tell your mom to send me a message, and I will clarify some more for you. All right?